Hope you're doing well. Welcome to this tutorial. We are going to talk about the if-else statement. So in the last tutorial, we learned about the if statement, and the if-else statement is just an expansion upon the capabilities of that really awesome function. So this is the control section. This is the first tutorial on the control section, and what the if-else statement allows us to do is have more control over how things happen in our program. So let's go ahead and jump right in. For this tutorial, you're going to need your Arduino board. I've got the Arduino Uno here. You can use any Arduino or clone, should work fine. I would recommend though sticking with the Arduino brand for these tutorials. That way we know we're on the same page. You're also going to need a potentiometer. The resistance range doesn't matter. You're going to need at least 3 jumper wires. You'll need a 220 ohm resistor, and you'll need an LED. Now technically you don't need the resistor and the LED. If your Arduino board has a built-in LED at pin 13, it probably does, but you can also add the resistor and the LED without any issues if you do have an LED there. So I like the external stuff, and you're also going to need one of those mallets that like a doctor uses to hit your knee. Alright, to set up this circuit, go ahead and take your potentiometer and put it in a breadboard, and the leftmost pin on the potentiometer hook to 5 volts, the rightmost pin hook that to ground, and then the middle pin, you want that to go to analog pin 0, so that's A0. And then you're going to want to hook your 220 ohm resistor to pin 13, and it doesn't matter which direction it goes. And then you're going to want to hook your light emitting diode, your LED, the short leg, that's called the cathode. You want that hooked up to the ground pin, and then you'll connect the long leg of the LED and the other free leg of the resistor with like an alligator clip, and then you can go ahead and plug that into your computer. So now go ahead and open up your Arduino IDE and go to File, Examples, Control, If Statement Conditional. And let's just start at the top. So the first big block of code is a very large multi-line comment. It's really not that big. It just looks big because this is a lot more than we're used to seeing, but it does a good job of explaining what the sketch is for, shows you how to set up the circuit, and then it also gives some attribution and lets us know that the code is in the public domain. And then it also links to a really helpful tutorial on the Arduino website that I highly recommend you take a look at. Anytime you get into a new program, definitely read the comments, see what the author had to tell you. Alright, so that's enough about the comments. So now we move on to the next block of code, and that is where we declare and initialize some variables. So these are kind of interesting. You see there's this const before the int keyword that we're familiar with. So that stands for constant. Okay, so what we're doing is we're defining some variables here, and we're calling them all constants. What constant is a qualifier of a variable. So the first line there, constant qualifies the integer analog pin. What it does is it protects the variable from ever being changed. And that might seem a little counterintuitive. Like, isn't the whole idea of having a variable so that it can change? Well, in some cases, you don't want your variables to change. You want them to be constants because you don't want at any point in the program a new number being assigned. And what can happen occasionally is by accident, you can assign a new value to something that shouldn't be changing. And so when you make something a constant, you protect yourself from future error if you know that that number will never change. So that's the whole idea of a constant. At first it seems a little odd, but in some cases, and in this case, it's a good it's a good time to use a constant. Okay, so we've got 3 constant integers. The first one is analog pin. We've set that equal to A0. That's where we have the middle pin of our potentiometer hooked up. We've got LED pin, so that's the pin that our LED is attached to. And then we have a threshold value. Now what we're going to do with this threshold value, basically what we're doing in this program is we're going to set a value within the range of the potentiometer, and to the left side of that value we are going to tell our LED to be off. and to the right side of that value, we're going to tell our LED to be on. And so that threshold determines that cutoff point. Okay, so those are the variable declaration and initializations. So moving on to the next block of code, we've got void setup. So void setup doesn't have too much going on here. We've got our good old pal pin mode. So again, pin mode sets the mode of a pin. And what pin? Well, LED pin, and that happens to be pin 13, and we're setting it as an output. Now, if you recall, all pins are by default set to be inputs. Okay, so we didn't have to do pin mode analog pin input. You don't have to do that. It's done by default. However, I personally like to do it. Now, it's not done here, but I like to explicitly say whatever pin I'm going to use, I like to set the mode. Not a requirement, but I like to do it just for my own benefit. So when I look at the code, I know, hey, it was set as an input or an output. Okay, and then the next thing we need to do is initialize our serial communication. So we use the begin function from the serial library, and we set the baud rate at 9600 because we're going to want to see information displayed to our computer from the Arduino. So that is the setup. Okay, now let's move on to the loop. Okay, so the first thing in the loop we do, and this should start to become familiar to you, the first thing we do is we initialize, or rather we declare and initialize a variable. So we're initializing a variable called analog value, and we're setting it equal to the output of the analog read function. Okay, so we've done this several times before. This should be old hat to you. So what we're doing is analog read is looking at the value that's at A0, so what it's reading the voltage there basically, and it's turning that into a number between 0 and 1023. So any number in between there based on the voltage from 0 to 5 volts, it's going to throw a number out there. So if there's 0 volts, it's going to return a 0. If there's 5 volts, it's going to return 1023, and if it's somewhere there in between, it's going to return that appropriately. So that should be pretty straightforward. So now the next line of code, and this is where we run into our if-else statement. So what we've got here, so first we're familiar with the if statement. So when we're looking at an if statement, the first thing we want to do, we look at that condition. What is the condition set by the if statement? So here it's asking, is the analog value greater than the threshold? So, well, what is analog value? Well, that's that integer that we just declared and initialized. So it's asking, is the value, is the voltage at your pin, at pin A0, is it at such a value that it's higher, it's going to be higher than the threshold? And when I say voltage, I actually mean the output value from analog read. So that's kind of a misnomer there. So is the analog value variable greater than the threshold? That's the condition. And if it is, what do you do? Well, look at the start curly bracket there right after the if statement, and then the next curly bracket one line below. What's the code in there? Well, that's digital write LED pin high. So digital write, that's going to apply 5 volts to a pin. Well, what pin? Well, LED pin, and that is pin 13. And, well, what kind of voltage is it going to write? Is it going to write high or low? It's going to write high. It's going to write 5 volts because we say high. If we wrote low, it would be 0 volts. Okay, so that's what gets executed if the analog value is greater than threshold. And in our case, threshold is 400. So if analog value is 401, then that LED at pin 13 is going to come on. Well, okay, well, what if it's not? What if that condition's not met? Then what? What else happens? Well, hey, look right after that if statement. After that second closed curly bracket, what do we see? We see the word else, and the word else is a keyword, okay? And then notice else, we've got another curly bracket. And then what do we have? We've got another command, and it says digital write LED pin low. So now we would be writing low voltage to pin 13, so that would turn the LED off. So let's reevaluate this condition. Basically what it's saying is if the analog value is greater than the threshold, it wants you to turn the LED pin high. It wants you to turn it on. And then if it's anything else, so if that condition is not met, so anything else, it wants you to write the analog pin low. So this is kind of a catch-all. So the condition here, the first condition, is going to specify what it wants you to do in that condition. And if that condition is not met, the else statement is everything else. So if the first one doesn't go, the second one will go for sure. Okay, so that's the if-else statement. Else is always going to get executed if that condition is not met. And if the condition is met, then the only thing that's going to get executed is what's in that first line, what's in between those first curly brackets. Okay, so I think that's enough about the if-else statement. Now, in later tutorials, there's actually an if-else-if statement. So you can set multiple conditions, but we're not going to talk about it now, just kind of keep you excited for the next tutorials here. More cool stuff down the road. Okay, so then once we've either turned the LED on or turned the LED off based on the position of our potentiometer, then what we're going to do is we are going to print that analog value to the serial port, because we want to make sure, like, is it working like we say? So when we see that the analog value printed on our computer screen is greater than 400, so it's like 402, we should expect when we look at our breadboard that the LED is going to be illuminated. And then when we have it less than that, we should expect the LED to be out. And so that just kind of helps us verify if our program's actually working right, if our program and our circuit are lining up. And then we have a delay, and then the delay just allows like a stability between the reads as if you happen to be turning that potentiometer quickly. Okay, so then that's the end of the program. So again, it would loop back over. We'd take a new value for the new position of the potentiometer in case you moved it, and then it would compare that new value against the threshold. If it's above the threshold, then it's going to write high, it's going to turn the LED on, and then if it's anything else, it's going to go ahead and turn that LED off. Okay, so that's pretty much it. Let's go ahead and verify this code and upload it, and then let's go ahead and serial monitor. Okay, so right now you can see here's 500, so I'm above the threshold and my LED is on. Now I'm gonna kind of lower it. Okay, I'm right there, so now I'm below and my LED goes off. What if I'm right, it's kind of at that junction where it gets a little interesting. You can actually get your LED to blink right at that junction, because the value that's getting read isn't always that stable. So you can see if you can get yours to blink. I know I can get mine to blink. But you can see when you go below, it goes out, and when you go above, it goes high. So that's pretty much it. This is a relatively short tutorial, kind of straight and to the point. Again, talking about the if-else statement. It really allows to give you another option with an if statement, a little more control, kind of like a default response if your condition isn't met. So that's it. Look forward to seeing you in the next tutorial, and make sure, please make sure, to do the try it on your own challenge. That's where you're really going to learn something. Alright, see you next time.
La 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 la.